if you could, we could talk a little bit about, no doubt this CANbus helps with preventive maintenance and predictive maintenance, with all of the data that it's collecting. So if we could talk a little bit about that, and if you might have any examples of where it helped with predictive maintenance for your end user.
The first advantage is normally, it is not a must, but normally when we speak about CANbus systems or CANbus components and onboard electronics on the component, then you normally have also sensors. It is not a must, it can also come without, but in a lot of components you have also then sensors, so you have some feedback from the component. Like we have it with our valve, where we have a sensor for the stroke of the main spool, and then you can of course see if the main spool is still moving like it should or starting to get some hysteresis, and then you see something is becoming more worse, or in bad case of course it starts sticking. And with this information, of course, you can a little bit calculate, okay, it is becoming more worse, perhaps we have to exchange it or not. To be honest, in a lot of components, hydraulic components, it is still not really a problem because they are designed for everlasting. So we have this discussion also on the pumps. And then I always ask, okay, please give me the feedback. What is your service case? Where is the component failing today and after? And normally they say, no, it is never failing. And say, okay, when it's not failing, then we have no topic for predictive maintenance.
Right.
But I think that's also something what has or will perhaps change, because this everlasting product also costs money. But at the moment, the hydraulic components are normally when, and this is the small limitation, or if the oil must be clean, and well temperatured. If the oil is in the right temperature range and the right contamination range, then you more or less have no wear on the components.
Mm-hmm.
But if this change, we have some things and we can do something and we discuss it with customer and we can say we have some errors and information we can send you, and then you can decide what to do with this information. Yeah, this discussion at least starts, but there are other components or branches which are using this much more, but mainly due to the fact that the components are not designed for everlasting. But that's a topic in agriculture. Yeah, it's perhaps starting now, but also on I know it from, for example, for crane manufacturers, and they discussing and thinking, okay, they have a certain crane structure, crane stiffness, and durability of the crane. And when they say we can do it more lightweight, but then we have to limit, or then we have to at least to check and to control that certain stress is not happen. And then again, our products help because we can limit and already check in the hydraulic component that the mechanical structure is not stressed. So this discussion is a different market, but this discussion is there and is a real topic.
Right. Well, these are probably, in addition to being used in agriculture, are used in a lot of other industries as well. So, yeah. Okay, that makes sense. So we were talking about the sensors, and maybe we could talk a little bit about the actuators and the features and benefits of the different sizes and actuators combined in one valve block supported by the modular system. So what would you say the features and benefits of that are?
Yeah, the biggest benefit of a modular system is, of course, the single components, the single sections in the case of the valve. They are there, they are existing, they are running in a high production quantity with a perfect quality behind, and they are always the same, more or less. We have an extremely big program, but everything is running. And then you can sit together with the customer and configure this valve block exactly to his needs, because it makes not sense to oversize it, for example, because you lose resolution, you lose performance, and you add cost and especially weight. I can, of course, use always one size bigger. but then he has to pay it. And yeah, so we have a very modular system from small valve up to big valve. We can combine it. And normally from the application coming, you see you have one or two big consumers and a lot of small consumers. Yeah, and to put then always the biggest block together, it's not sensible from different reasons. It's also efficiency. Um, and this is an advantage. We can put these different sizes together. It is very simple from layout, from engineering work also. It is easy to understand how it works, and you can really find together with the customer very fast the right setup of this modular system. And I would, to be honest, say I think we never sold one block twice. Twice means to a different customer. Of course, it's the same machine, same customer. Of course, we have serial business, but this block and this combination you will not sell to any other, even not when it is the same machine from two customers, because the machine producers have also their own idea how the machine should work, how they should perhaps also differentiate from his competitor. But with our module system, we can also always take out of the stock the right configuration and put it together
Right,
and
and
give
put
it
it
to him.
together.
And he can rely on a stable production process and that he get always the same quality, independent if he use a small or bigger size valve or pump. It is always, yeah, same, I would say. But the advantage is really to, on a simple way, finding the right setup for the need of the customer's machine.
And so how do you go about doing that? Do you have a representative that goes out and like goes out to see how the conditions are going to be and what the crop is and all that, and then you design it together? Or
Yeah, we have a big sales network and sales responsible in each region. These guys are already good skilled in our products, of course. So they are not only pure sales guys, so they are technical sales guys. They know our products very well. And I would say in 80% of the cases, they are able to discuss with the customer about its needs. Normally, you start with the machine, with a hydraulic schematic, perhaps with the current situation and problems, and what should be improved. And then we have tools which supports also the sales guy, so he can configure, and the tools has also some intelligence, so things which are not possible to combine, for example, are not possible to choose in the tool. And in a lot of cases, our sales guys know how to handle it. And if not, of course, they can ask in our in the central in our main office and ask for help. And then we have a back office, of course, which help or which, like me, also go out together with the sales guy and visit the customer. And this is also a truth. Beside our extremely big standard modular system, we have a lot of specific design for one customer. So spools, adaptation on add-on blocks, on a lot of things we do customized also.
right. Great, thank you. So what would you say, in what ways can hydraulic controls be used to pre-select different settings and working modes in agricultural machinery, especially in the self-regulating systems that automatically react to those changing conditions?
Yeah, one big advantage of now back to the product with CANbus electronic with sensors, they are more precise and they are also calibrated on our test benches. So a lot of hydraulic, mechanic features, we put it in the box, we calibrate it, put it on the software, and the component is then a very good performing black box. So you put a signal into it and there's a clear output. And the or the machine builder has not to think about all the hydraulic specific non-conformities. And this now helps in that way that you can more easy parameterize the component. So for example, you say I have an application which needs 50 liter per minute because this is this maximum speed. I want to reach a certain maximum speed from the cylinder. With the cylinder size, that means this volume flow, 50 liter per minute. Then you have defined the maximum speed. But in most of the cases, you will not drive the cylinder with maximum speed. You will drive it very precise, especially when we now talk about smart farming with very precise. It must be fast in a certain point. So the farmer is not willing to wait a long time till the machine can work. But when he work, it must be precise. Pure, simple hydraulic components have some problems with this. And now talking about this, especially PSL CAN, where we have this calibration integrated in the onboard electronic, you can really run this high speed, low speed in between and make a parameterization. You can also say a good driver can use it, for example, up to 50 liter because, okay, he can handle this speed. A not so good skilled driver can perhaps only use it up to 30 liter. So reduced by 30–40%. But the precision is the same. Normally, you normally should then choose a smaller valve, but this is of course not possible. Nobody will go there and say, okay, this is now another driver, then I put another valve inside. So in the past, you have to choose before and to think what should the performance of the machine, and the change was difficult. Now, with these more precise smart components, you can also make more personalization on the machine, up to that the driver gets his own key, go to the machine, start the machine, and there are setting parameters which change something depending perhaps on his skills or own feeling or wish. And this is something what is also possible. Here we have an example from also another industry where we talk about walking excavators, very specific excavators, where the driver can set this excavator completely to his feeling in a lot of parameters, store it on his key, and another driver can completely put the machine in a different way, set up.
A different
But
mode,
it's,
yeah.
but it's always the same hardware.
Wow.
And I would say this is also some of these big advantages of these technology, what we normally call CAN, but CAN is only the communication. CAN is not the complete story. It is about onboard electronics, sensors, closed loop systems, or
Great.
closed loop controls.